In this video, I want to cover the topics of z-scores, unusual values, and introduce and explain how to use the freeze function in Excel. All right, so let's look at this problem. The annual average snowfall since the late 1800s in Denver has been 56.59 inches per year with a standard deviation of 18.59 inches. The annual accumulations of snow for the years 2000 to 2020 are given here in column B. Now the question, are there any years with unusually high or unusually low amounts of snow? So let's start with this word, unusually. What is the statistical definition of the word unusual? Well, an unusual value is any value in a set that is more than 2 standard deviations away from the mean. So that could be above the mean, above average by at least 2 standard deviations, or below the mean by at least 2 standard deviations. Now, this whole idea of z-scores, well, the z-score for a specific x value is how far that x value is from the mean in terms of standard deviations. So if we look at this first x value and the mean, well, it's above the mean. It's above the mean by about 1 inch. Well, instead of saying it's above the mean by 1 inch, well, how many standard deviations above the mean is that? So we want to convert each one, somebody erase this, we want to convert each one of these x values to a z-score. Now remember, no matter how big your data set is, there is one mean and there is one standard deviation. But there is a z-score for each data value. So in this case, we have 21 numbers in our set, so there's going to be 21 z-scores. And our formula for z-score, if we want to convert an x value to a z-score, well, z is equal to, we take the x value that we're trying to convert, subtract the mean, and then divide that by the standard deviation. All right, so that's the calculation that we want to apply here in column C. All right, so let's just type in what's given in the problem. We're given that the mean is 56.59, and we're also given that the standard deviation is 18.59. All right, so now if we look at this cell right here, C2, we have all 3 numbers that we need. We have the x value, which is the 57.6, we have the mean, and we have the standard deviation. So applying this z-score formula to just that first x value. Now we want that z-score to equal, I'll use parentheses. I'm going to actually put parentheses in the formula. We'll put parentheses there so we can follow order of operations. The z-score is equal to the x value minus the mean, that's the numerator of the fraction, and then we divide that by the standard deviation here in F3. So B2 minus F2 divided by F3, that's the location of those 3 numbers, x, x bar, and s. All right, actually okay, so the first x value has a z-score of 0.05. Now what I just typed in, I typed in equal parentheses, the x value, which was location B2, minus the mean, which is up here in location F2, and divided that by the standard deviation, which is in F3. Okay. So we've got our first z-score. We need 20 more z-scores. So we need to apply this formula 20 more times. Now, rather than type it in individually for each x value, we could have Excel repeat this calculation 20 more times by hovering the cursor over the bottom right corner till that little white plus sign turns black. Click and drag it down, and Excel will repeat the formula. The problem is, if I do that, I'm going to get error messages. That error message is dividing by 0. And the reason that we're getting an error message here is because when you drag a formula down, Excel increases the index by 1 for each row. So what happened is when I drug that down was the B2 became a B3. That's what we wanted, the next X value. But the F2 became an F3, and the F3 became an F4. And then the next line became B4 minus F4 divided by F5. Well, there's nothing in F4 and there's nothing in F5. So we don't want these F's to increase in value. We don't want the index on the F to increase in value. This is not what we want. What we want. Now let me erase this and let's give what we want to happen. I'll put it in green. This is good. Okay, we want the next X value. So we want that B2 to turn into a B3. But we want to use the same mean. So we want the mean to remain F2. And we want the standard deviation to remain F3. And then on the next line, we want the next X value, which is in location B4. But we want the same mean and the same standard deviation. So how do we do that? How do we let the B values, the B index, go from 2 to 3 to 4 to 5 to 6 and so on, but the F2 to stay F2 and the F3 to stay F3? The way we do that is to freeze the index on the F2 and to freeze the index on the F3. And we do that with a simple one-character $sign. So the $sign freezes a number in Excel. So if we put a $sign before the 2 in our formula and a $sign before the 3 in our formula. So let me go back up to cell C2. And so the formula for C2 is up here. So what I'm going to do is, in that formula, I'm going to use the mouse to put it where I want it, put the cursor where I want it, and I'll add a $sign right there before the 2, and I'll add a $sign right there before the 3. Now, I get the same z-score, 0.05, but now when I drag this down, we get z-scores. And that's what we wanted. So now the next line is B3 minus F2 over F3. And then the next line is B4 minus F2 over F3. Okay, and that's what we wanted. So now if you click on any one of these z-scores in the formula up here, you'll see the B index corresponds to the correct row, but the F2 remains F2 and the F3 remains F3. All right, so that does it for the finding the z-score portion of the video. And now it will be a very quick answer to this question. Are there any years with unusually high or unusually low amounts of snow? Well, like I said, the statistics definition of the word unusual is more than 2 standard deviations, either above or below the mean. And since z-score is number of standard deviations, then we say that, well, no, there are no years with unusually high or unusually low values of snowfall, because there are no z-scores that are 2 or above, which would be above the mean, and there's no z-scores -2 or below, which would be below the mean. The closest we have, it looks like, is this amount of snowfall in 2016-17, 21.8 inches was close to being unusual. because it was close to a z-score of -2, but it wasn't extreme enough to be considered unusual. All right, so that does it for this problem. 3 things we talked about, just to review. We talked about finding z-scores using this formula. We talked about the definition of unusual values and the use of the $sign. And the $sign we use when we're having Excel repeat a formula that we typed in once whenever we don't want the index to change. All right, I hope this was helpful.